All right, we have folks coming in. It's time to get started, and I want to welcome you all to the Microsoft DevOps User Group. My name is Jeffrey Palermo. I'm your host, and we have a really exciting presentation this month. Just a little bit about the Microsoft DevOps User Group. We are a virtual user group that focuses on expanding the adoption of DevOps methods for folks using custom software on Microsoft technologies. So if you are a .NET developer or use Visual Studio for any purpose whatsoever and deploy to Azure or Windows servers in any various numbers of data centers, this user group is for you, and we try to get the best content, the best educators to help adopt those methods. And if you have any feedback for topics or presenters that would be good to put on the schedule, then please reach out via the Meetup group. I have that here in the browser at the moment, and you can log into meetup.com and contact us, and make sure to tell your friends and colleagues to join the group for notifications. We have one presentation per month, and these are recorded and placed on our YouTube channel. And so you can, the group is sponsored by ClearMeasure, and there's a playlist on youtube.com/ClearMeasure. And as we have Brian Harry's presentation, and we also have Damian Brady's presentation on deploying with VSTS and Azure. And shortly, in a short period of time after this presentation, we will get this edited and uploaded to the playlist as well. So I want to introduce our speaker, and really excited about this content. But Matt Wrock is a software developer at Chef, working on the Habitat team and focusing on Habitat's Windows compatibility. Matt's been an avid open source contributor and has contributed to projects including Chef, Vagrant, Test Kitchen, and the WinRM Ruby gem. Matt has over 18 years of professional developer experience, ranging from high traffic distributed web applications and online advertising and Microsoft websites to infrastructure and application automation. So Matt is going to talk to us today about continuously deploying .NET applications with Habitat. And as we go throughout the presentation, please open the Q&A window and put in your questions, and at various stopping points, Matt will ask for questions. In addition, you can look for the chat feature and put those in the chat window as well. So Matt, thank you so much for presenting to us, and I will turn over the screen to you at this time.
Great. Well, thanks a bunch, Jeffrey. And thanks so much for inviting me to talk to this group. I'm really looking forward to it. Excited to talk about Habitat on Windows. This is actually the first live demonstration that I've done of Habitat on Windows, so it should be exciting for everybody, and hopefully not too exciting. But so at any rate, yeah, I'm thrilled to talk about this. It's the first one since we've gone live with Windows on Habitat. We've done a few blog posts. But pretty much my entire presentation is going to be a demo. So let's jump into it. So what I want to talk about today is using Habitat to facilitate continuous deployment of a .NET application. So we're going to be taking an ASP.NET Core application. It's going to be talking to MySQL, and we're going to deploy that out to Azure servers using Habitat. And we're also going to deploy it to containers. Now, just to clarify, so while I am going to be using .NET Core and MySQL, those make for a good, they're quick, they're fast, they make for a good demo. You can totally use Habitat with full framework, with IIS. We have blog pieces where I cover that. If by chance you find yourself at ChefConf this year, you can actually see that, and if not, you can see the video afterwards. So with that, let me dive into all this stuff. And first of all, what some of you may be wondering, if not maybe all of you, is what is Habitat? So I'm going to assume that nobody has worked with Habitat, and maybe nobody has even heard of Habitat. Obviously, if you've seen tweets about this meeting, I guess you've heard of Habitat. But I'm going to assume that most of you have probably heard about Chef. If you haven't heard about Chef, I'm sure you've heard of a Puppet or Ansible, or I would imagine this group has certainly heard of PowerShell desired state configuration. So all of those products I just mentioned, except for Habitat, fall within that family of configuration management. And really their aim is to make a server a certain way, to fall into a particular desired state. And the whole center of that automation is the server, it's the node. And so what differentiates Habitat from those products, in a sense, its end goal is very similar. It's trying to make a kind of a turnkey process, automate your servers into an end state. But instead of the server being the center of automation, it's really an application being the center of automation. It's really about automating your applications, and it manages the whole lifespan of your application. So all the way back from building your application and packaging your application to providing an artifact repository to store your application and deploying from that repository to actually running your application inside of either bare metal or a VM or a container using the Habitat supervisor. So that said, Habitat covers quite a large surface area, which can make Habitat a challenge to talk about. But I'm going to actually kind of lead you through all this stuff. And actually, let me before I go forward, let me share my screen. Let's see. There we go. So this is my one slide, I want to just kind of point out some of these details before I actually dive into, before we put our hands on a keyboard, so to speak. I'm going to kind of be giving you a whirlwind tour, so to speak, of Habitat. We're not going to be covering all the nitty-gritty details, and so you may see things throughout the demo that pique your interest or may seem a little bit confusing. And if for some reason you miss anything or you're not able to get your question answered here, we do have a website, habitat.sh, where we have all sorts of documentation and tutorials. And we even have a tutorial now on an ASP.NET Core on Windows application. So there's that. There's a Slack community that we have, and the link for that is on the slide, habitat-sh.slack.com. And then all the code that I'm going to be showing in this demonstration is inside this repository, github.com/habitat-sh, and the repo name is habitat-aspnet-sample. So, and my Twitter address is mrockx, and my blog is hurryupandwait.io. So with that, I am going to switch over to my Habitat dev environment. Let's see here. Come on, Mr. VM. There we go. Okay, all right, great. So this, where we are now, I just jumped into a VM. I've noticed that when I do audio video sharing, my CPU cycles tend to take a nosedive. So this is a hope that doing all this inside of a VM may protect us from long builds and things of that nature. But so in this VM, I have a typical development setup. So here you can see I've got a PowerShell script, and this PowerShell script is what we call a plan. And in Habitat, a plan is really you can think of it as the basic building block to creating a Habitat package. And the plans come in two flavors. They come in PowerShell and they come in Bash. So it really depends on what platform you're targeting. So if you're targeting Windows, you're going to use PowerShell, like we're going to do today. If you're targeting Linux, you would use a Bash script. However, regardless of whether or not you're using Bash or PowerShell, they basically look the same, and they have the exact same structure. And in this plan, that we're looking at right now, there's really two key sections, and it's fairly obvious actually when you look at it. You see a bunch of variable assignments towards the top, and then you see a couple function definitions at the bottom. And so what we're doing at the top is we're laying out essentially metadata that describes the package that we're going to build for our ASP.NET application, and describes some information that the supervisor that will eventually run this application will need to know about the application. So what do we have here? We have first some identifying information, name, origin. You can think of origin as it's like a GitHub organization, basically like a root of ownership. So I'm using my personal origin, Wrock. But your origin might be, real origin might be the name of your company. We have a lot of stuff that you would expect to see in any packaging system. Chocolatey, nougat, you would expect to see things like maintainers, license, stuff like that. That's not really that interesting, so I'll kind of skip past that. And I'll get that down to the package depths and package build depths. So while a lot of packaging systems will allow you to express dependencies, one thing that's unique with Habitat is you can express, you can divide your dependencies into build time dependencies and to runtime dependencies. So, because one thing that you can do with Habitat is as part of the packaging process, you can actually build your application. And as a lot of us know, when we're building an application, we may have a lot of dependencies just to do that build that we're not ever going to need at runtime, and so we don't need to pull those down onto a production server. So, for example, here our runtime dependency, our package depths, is going to be simply the .NET Core runtime, and these are Habitat packages themselves. So we packaged that runtime as a Habitat package. Our build time dependency would be the .NET Core SDK. So if this was, for example, a Java app, you would imagine, I'd have the JRE as my runtime dependency, the JDK for my build time dependency. If this was a full framework application for my build time dependency, I might include the Visual Studio build tools. I might include NuGet, but one of the nice things about .NET Core is pretty much all I need is that .NET utility, and that does everything for me. So that's dependencies. Next, we have exports and binds, and this uncovers really a powerful concept in Habitat, and that's the concept of binding. So if we go back to the beginning when I talked about Habitat, what Habitat is, it's a means of automating your application. When we think about what that really means today, I mean, when we think about the applications that we run, our applications are much more than the particular, for example, here, the particular binaries that this is going to compile down to. So this particular application is not going to do a lot on its own. Like, if it doesn't have a database, it's basically going to be worthless. And so a lot of our applications, as we well know, they need a database. If you're going to have any kind of traffic, you might need caching services. You might be using some kind of messaging or queuing services. You might be using software-based load balancer. Maybe Nginx or HA proxy to manage traffic for your services. So what Habitat allows you to do with its supervisors is allow you to codify those relationships where you can have different services discovering one another and connecting and interacting with one another. And so that discovery and that interaction is facilitated by what in Habitat we call binding. And so this binding, you could kind of think of it as a contract between two services, and you have a producer side of that contract and a consumer side of that contract. And so in this case, for example, so in this ASP.NET Core app that we're about to build, it might have a producer relationship with, let's say, a software-based load balancer. So a little bit later in this demo, I'm going to show us load balancing three VMs hosting this application. And so we're going to use HA proxy to do that load balancing. And what HA proxy is going to need to know, it's going to need to know what port our application is running to. So as we send traffic to port 8080 to HA proxy, it's going to need to know what port to send to fan that traffic out to our individual web servers. So this package export basically is part of the contract where we say, okay, this is the property that I'm going to expose to consuming services. And likewise, my application is also going to be a consumer. So my ASP.NET application is going to need to consume a database. And it's going to have certain expectations of that database. And in my package binds, I basically express what those expectations are. I basically say, I'm going to expect a database. So on the left-hand side, the equal sign there is what we call our binding alias. And we'll get a little bit in the demo when we actually run this application. We'll see how that actually gets used in a nuts and bolts kind of a way. But we're saying that we expect a database to expose to us a username, password, and port, which is clearly going to help us be able to construct a valid connection string to connect to that database. And so in just a bit, we'll kind of see how that all fleshes itself out. But this is, in this plan is where we basically express the possibility of these relationships. There's other metadata that we can express. This is really all we need for this plan. Again, I'm not going to go through every single nick and cranny on these, what we see next here in these functions, these are our build time callbacks. So as I mentioned, you can use Habitat to actually build your source code. Now, you don't have to. There's some build processes out there. Maybe you're working with commercial off-the-shelf software, and you don't even have access to the source. When you just basically want to repackage that software as a Habitat package, you can certainly do that. In this scenario that I'm going to cover, we're actually going to build from source. So I have the full source tree of this magnificent application that we'll see in a bit. But so there's nothing in Habitat that intrinsically knows anything about .NET Core. You can build .NET Core, you can build Go, Ruby, C++. I can't really think of any platform that you couldn't build for Habitat. But Habitat doesn't know anything special about those platforms. So this is where we, as the application developers, essentially tell Habitat, share our knowledge, because we know how to build our application. And so here we can override a variety of functions. For this application, I just need to override these two functions. There's many more that are available to me. Again, if you're curious about all the things you can do throughout the build process, take a look at our docs. But invoke build. So this is the part where we tell Habitat how to basically produce our binaries. And so here we're essentially going to use our .NET executable that we're going to do. If anybody here is familiar with .NET Core or has used .NET Core, you'll know that you got to do a .NET restore and a .NET build. Those are the key phases of actually doing your output. Now, if this was a full framework app, here I would be calling out to MS build. And because I have .NET Core SDK in my build dependencies, I know that I have access to that. So I know that if that was not on the build machine when I invoke this build, it will pull that down. And it also will pull down any runtime dependencies. And the great thing about Habitat is that then when I actually do run it, if the runtime dependencies aren't present in my runtime environment, it not only will download that runtime dependency, but will make sure and download the exact same version that I built with. So there's no surprises there, so to speak. So we do the build, and then at the very end here in the invoke install, so we have our build artifacts. They've been produced. Now we essentially need to lay them out on disk and make sure that they get put inside of our package correctly. And so we do a .NET publish to do that, where it basically takes all the artifacts and lays them out. We basically tell it to plop it into this variable package prefix, which is it's a Habitat variable that will expand to essentially the staging area of your package. So whatever you put into that directory, you can be guaranteed that that will bind itself into the final habitat package, which is a single file, a heart file. So let me pause real quick. I saw a few things in the chats. If there's anything I need to, I see the Q&A. I don't see the chat for some reason. Oh, well, I'm gonna continue on. Jeffrey, if you've seen anything, just stop me. Let's so yeah, so
the only request we have is if at certain times the text can be made larger or zoom in. That's the only question we have so far.
Oh, okay. Let's see if I'm in a VM here, but I think I can make whoops. What's the trick to do that in Visual Studio Code? I think it's Shift or Alt zoom. I move the zoom. Let's see. There we go. View, zoom in.
Perfect.
Let's try one more. Okay. All right. There we go. Now I'm going to, but actually now I'm going to leave the screen. So what I want to do next, hold on one second. Let me get to the right one. And shoot, this is probably looking a little small. Well, rather than fiddling around, I probably should have spent a little bit more time trying to adjust the resolution of this VM. But what I will do is I'll just make sure.
That viewer is okay now.
Okay. Oh, it is? Okay. Excellent.
That viewer is okay now.
Okay, cool. So we've gone over this plan. Let's actually build it and see like how this actually works out. So the first thing I'm going to do, so I'm bringing up a PowerShell console here, and the first thing I'm going to do is I'm going to go into what we call a Habitat Studio. So a Habitat Studio is where you typically actually do a build, and a Habitat Studio you can think of as a clean room environment. So in Windows, what we do is we do a few things depending on how you enter the studio. Let's first just enter in. So I'm going to say Hab Studio enter -W. I'll explain what that -W is in just a bit. But this enters the studio, and so basically now where I am, I'm inside of a PowerShell core 6 prompt. So everything that Habitat does with PowerShell is done with PowerShell Core 6. The reason why is because we can actually build PowerShell Core 6. We know exactly all the commandlets that are in PowerShell Core 6. So we can put that on different operating systems so that we don't have to ask ourselves the question, well, gee, what version of Windows are you running? Therefore, what version of PowerShell are you running? We always know what version of PowerShell that we're dealing with. So that's convenient. Well, it's convenient until there's some commandlet that you want to use that's not in PowerShell Core. But if you've worked with PowerShell Core, there's ways around that. There's ways to kind of remote out, so to speak, to Windows PowerShell if you really need those commandlets. But at any rate, so this is PowerShell Core, and we've also trimmed the path. So the only thing on my path, so in your build agent, for example, you might have a ton of stuff on your path, all sorts of utilities and things like that that you know that you need to have present in order to build your application. But what we want to protect you from in Habitat is doing a build, having it link or finding those utilities on your path that it might need not only at build time but also at runtime. Having you, because I know I have, and maybe many of us have had this experience in the past. You then ship that application off to a staging or, God forbid, a production environment, and then poof, nothing works because you didn't have that dependency that or the right version of that dependency that you had at build time or test time, for that matter, at runtime. And so basically what we try to do here is we try to give you nothing. So basically all that's on the path here is Habitat, C/Windows, and C/Windows System 32. And then when you actually run the build, it'll go through the dependencies that you've declared in your plan, and it'll add those things onto the path. So the whole idea is that you have a minimal environment that can be easily reproducible. Now, let me explain real quick what that -W was that I entered up here. So this basically is telling Habitat, put me into a local Windows Studio. Now I can get really fancy and really clean if I leave that -W off. And as long as I have Docker running and I have it running in Windows container mode, what it will do instead is it'll actually drop me into a Windows Server Core container. And so then I don't have to worry about, because I think we've all had this experience where things leak into Windows System 32, things leak into the registry, but in a containerized studio, things are truly clean. It would mount everything to the directory from which I entered the studio. So I still have access to all my code. The reason why I didn't do that here is because there's a startup penalty with entering into a container. So with Windows containers, now I'm on a 2016 VM, so they start up okay, 10, 15 seconds. There's a bug actually in the current release of Habitat that makes that a little longer, but though we have a bug fix coming out for that today. But if you're on Windows 10, you're going to be using containers in what's called Hyper-V isolation mode, where not only does it where the container is hosted in a minimal VM. All of this is minimal. It's much faster than a full OS, but we're still talking, it can be 30 seconds. And there's no reason for all of us to wait together doing that, even though I guess I could have done it while we just talked about that. But because I'm in a VM, because I know about this VM, so I started this VM a few days ago, I know that the only thing I have installed on this VM is Chocolatey, Habitat, and Visual Studio Code. So I feel pretty good about the cleanliness of this VM, and -W basically gets me into it almost instantaneously. So that all said, let's actually build this plan. So I'm gonna just, this should be fairly intuitive, I think, I hope. I'm just gonna say build. So by typing build, what Habitat does, it's gonna look for a file called plan.ps1 inside the root of my repository and where I currently am. If it doesn't find it there, which it won't in my case, it will then fall back to a directory called Habitat. And it will look for a plan.ps1 there, which is where it found this one. So if you're looking at this, so what it's doing, it looks like it's actually doing the build now. So it's doing its .NET restore, which I think it just finished. So now it's doing the .NET build. So I can finish that. Now it's doing the .NET publish and finish that. And now it's in the last phase, it's generating the package artifact. So here is where it takes all those build artifacts, it compacts them down into that single heart file. Not only does it produce that single heart file, but it actually installs that package into my local studio Habitat environment. And now we're done. So so that's great. It built my package. Let's actually run this package. So when we entered into the studio, what Habitat did, it also started up a supervisor in the background. And I can take a look and see what's going on with the supervisor by just doing a hab sup status, and should be doing nothing. Yeah, so it's doing nothing. No services are loaded. So before I can actually run the package that I just built, I actually have to have MySQL running because my package isn't going to do a whole lot without a database. So that's the first thing I'm going to do. I'm just going to say hab service start core/MySQL. And that starts up MySQL. So now I'm good to start up my application. So I'm going to say hab service start, my origin, which was mrock, / my package name, which was habitat -ASP.NET -sample. And here I'm going to provide one more argument. So I'm going to provide a bind argument. So this goes back to that binding we talked about. We saw in our plan here where we said, hey, we're going to expect to consume a database, and we're going to expect that to have a username, password, and port. And so now what I'm going to do at runtime, I'm going to say, hey, remember that bind that I mentioned? So my binding alias database that I used, I'll type that, :, and this is where I tell it the service that it can find that will actually fulfill its end of the contract, so to speak. So that's MySQL. So I'm going to say you're going to, the database binding that you should find will be MySQL.default. And great. So now it starts that. Now you'll notice as I've started these applications, we're not seeing a whole lot of output. It's basically saying, thank you very much. I've forwarded your requests onto the Habitat supervisor. If you really want more details, take a look at it. So let's actually do that. So in the studio, we expose a helper function called get supervisor log. And oh, good, this all worked. I'm a horrible typist, and I'll type things wrong as a habit of mine, and things that I don't want to see end up showing up on my monitor. But this is exactly what we want to see. So, so what we see here is the output of the supervisor. It's live streaming this output, so I see up here towards the top the supervisor starting. I see it's starting up MySQL, and lastly towards the bottom I see it actually starting the Kestrel web server that's running our ASP.NET core application. Now one thing you might be wondering, well, how the heck did it start up the Kestrel? How the heck did it start up the .NET application? Like we didn't tell it how to do that. Well, we actually did. I just didn't talk about it. So I'll go real quick back to the editor here. So this plan that we saw, this is the bit of code that we would write as an application developer or an operator that describes how to build our application. There's other code that we can write that tells Habitat how to deal with our application at runtime. So when your application gets started by the supervisor has a few different moments in the life cycle of the application that we can put a hook into and say, hey, run this code. There's all sorts of those hooks. So we've got initialization, we've got run, we've got post run, we've got stop. I'm not going to go all over over those. All of them. I'm just going to show you our run hook. So this run hook gets run by the supervisor when it tries to run our application. Now, what this also is, this is a template. We're using the handlebars templating language, so that's why you see these double brackets. So these double brackets are this whole file really. When the supervisor starts up our service, it passes this file through its rendering engine, and it will fill in these templating areas. And again, I'm not going to go over the details of what service var path, service config path, all those things are. You can look that up in our documentation. But Habitat will expand all those. But what's key here is at the end, it's gonna call .NET. So again, because we have the .NET core on our declared as a runtime dependency, we can know that when we're running our application, .NET is on the path. So I can call .NET and I'll get the exact same version of .NET that I had present when I built my application. So that can be reassuring. And it will give it the package name.dll. And actually what we can do here, we can actually see what it rendered. So I'm just gonna cat this out, cat service. This is where the supervisor actually puts our application. Look at the hooks, run. So there is the output of that after it's gone through the Habitat templating engine. So it calls .NET on basically our DLL, which if for an ASP.NET core application that will start up the Kestrel web server. So we got the output that we wanted to see with the supervisor, but did the things actually happen? Let's take a look. So let's go to our web browser. Let's go to localhost. Of course, I use only the finest of web browsers. And I'm gonna. So this is 0.2.7. Quick, it's noteworthy to note that I built 0.2.8. So I'm gonna do a refresh here. And there we go. So I have 0.2.8. It's running. So that's great. Everything looks great in my development environment. So now let's let's continuous deploy this guy. Let's actually get this out into our Azure infrastructure. So we're about to do some typey to do all this. In the real world, this would be the job of your VSTS or your TeamCity or your Jenkins nodes to do this. But let me just show you what I have out there in Azure. So here is basically my demo resource group, all the VMs that I have running. So this dev VM, this is the VM that we've been on. We have ASP.NET 1, 2, and 3. These are, we have a supervisor running on all three of these, actually running our application, 0.2.7 right now. We have HA Proxy also running a supervisor. This is actually, now one thing that's worth noting, this is a Linux machine, this HA Proxy machine. But you can have Linux and Windows services all commingled talking to each other. It doesn't matter because the actual Habitat, gossiping language is just TCP IP. So we all understand that. And we have another VM running MySQL. So let me go back to my VM. And I'm going to switch desktops on the VM. And I apologize, this might be rather small for everyone to see, but just I'll describe what's happening here. I wouldn't even try to take in all the details. But these three, so I have three consoles. And I'm remoted in to ASP.NET 1 on the upper left, ASP.NET 2 on the upper right, and ASP.NET 3 on the bottom right. And so basically the only thing that we really want to see here is start to see movement once they actually see the new version of our application. And so in order for them to do that, we need to put the application that we just built, we need to put that application into the Habitat depot. So I'm going to do that right now. I'm going to say hab package upload, and I'm going to give it the path to my heart file. So this guy right here, and unfortunately because I'm using the stock console, copy and paste is not all that I would like it to be, but I have tab completion at least, and I can find 0.2.8. There we go. So so it's going off to the depot, but this still isn't going to cause our supervisors to update themselves. And let's think about why that might be. So what did I do? I just built something. We can pretend that this VM is my laptop. I'm just some dude on the dev team that built this application, and now I'm pushing it to the depot. Maybe the best default behavior is not to have that automatically update my production systems. And so Habitat kind of builds these safety mechanisms in for you by using a concept we call channels. Habitat will give you two channels by default. It gives you a stable channel and an unstable channel, and you can create as many channels as you want. You might create a channel for all of your different environments. But by default, when I upload a package to the Habitat depot, it goes to the unstable channel. And by default, when I tell my supervisors to look for an update, they'll look in the stable channel. So in order for my supervisors to actually see this update, I have to promote this package. So I'm going to do that right now. Again, this would be things that would be typically handled, in a production scenario, by your pipeline, whatever infrastructure you have running your pipeline. But this fits nicely into that. But so I'm going to say hab package promote. I'm going to give it the full identifier because it needs to know the full version and release of my package. And then I'll give it the channel that I want it to promote to, so stable. Okay, great. So that went to stable. So now let's go over here. And what's happening with these supervisors? So these supervisors, when I started these supervisors, I added an argument that we haven't seen that's called a strategy, also known as an update strategy. And the default update strategy, if we don't give it one, is none. You do not update yourself. Just run whatever version you're running till the end of time. But what I gave it a rolling update strategy. Because what I want to have happen, I want these three nodes to update themselves one at a time. Because if they all updated themselves at once, which is actually the at-once strategy, if they did that, then what would happen is they would all restart themselves, or possibly all restart themselves at the same time, which means they would all go down at the same time, which means I would have an outage, which is not the desired scenario that we want. Okay, so we see, so they ping that. So these three are basically elected among themselves an update leader. that update leader is the one that watches for an update. When it sees an update, it goes through its followers one by one and makes sure that they get updated. And then when the last follower updates itself, it will then update itself. And so, so at any rate, so now, okay, let's see. So I see this guy updated itself. For some reason, I'm not seeing these guys, and this is, we'll just see what happens here. So let's go back to our browser. And so in this browser, I'm running 0.2.7, and here I'm pointing to 10.2.9, which is a private IP on my network. This is the IP that HA proxy runs on. So HA proxy is running on port 8080. It's looking, so it's the one that's receiving the, if these were to have public IPs, this is the one that would give a public IP. And it has also discovered my three nodes, and it's going to fan out that traffic across those nodes. So let me refresh this. What I hope to see is a 0.2.8. And I'm not seeing that. Just sometimes if I let this run like overnight, which I have, they lose their MySQL connection, and then the app kind of, it's like IIS, if nothing runs through it, it eventually dies and they have to start themselves up again. Okay, we see one has updated themselves. Okay, well, anyways, I'm gonna kind of, we'll let that go. This is the first run through I've done of this where I've seen that happen. But in the best case scenario, they all update themselves one by one, and then we have 0.2.8 running on all of the nodes. I need to something weird going on in my environment that's preventing it from where one of them missed an update. But anyway, we can move on. So I basically have shown you everything, just about everything that I want to show you. I want to show you one last thing. And the nice thing about Habitat, this is kind of it's basically a big concept, but there's not much to say about it. And that is running this stuff inside of a container. So because Habitat has created this kind of isolatable environment, it makes it easy for Habitat to just throw that into a container without us doing really anything. So there's just one command that we need to run. I'm not going to run that command now. I've already run it. The reason, because it takes a few minutes to create the image. But if I were to run hab package export Docker, so if I could export my package to the Docker format and I give it the package name, what Habitat will do is it will create, it starts off with a base image, so a base Windows Server Core Windows container image. It then adds to that the Habitat launcher and supervisor. So basically all the Habitat goo that Habitat needs to be Habitat. And then it adds to that your package along with this entire dependency tree. So in the end, what you have is you have a container image that has everything that it needs to run. And in this case, the case of this app, we have two containers that we need. So we need an image for MySQL and an image for our application. I actually already have MySQL running. So if we look in this console, I've done a Docker PS already. This is MySQL, my MySQL container running. I could show you, I could do a Docker image ls and show you the image that we have. So here's our Habitat ASP.NET sample. We give it the same image name as our origin package name. I also did up above here, I did the kind of the Docker one-liner trick for getting the IP address of the container. So here I have its IP address, which is I'm gonna need. And now I'm gonna move into another console. And in case you can't see this, this is just one line that we have to launch. So basically I'm gonna say Docker run -IT, so -IT, so we can kind of see all this interactively. I'm going to give it the container, the image name. So this is the name of, it's the origin and package name of my image. Give it that same bind argument that we saw before, and this new argument peer. So here we have two supervisors running in two different containers. In order for those supervisors to connect with each other, the new supervisor coming in needs to know the IP address or host name of any supervisor inside what we call the habitat ring. So we could have a ring of 100 supervisors, as we saw in my Azure console before. I've got a ring that we just looked at. It had about 5 or 6 supervisors running. So it just has to have the IP of any of those. So we just copied, there's only one other supervisor running in this ring, which is the MySQL one. So we'll put that one in there and we'll hit enter. So now it's gonna do its thing. This takes about 10 seconds where it starts up. Okay, there we go. So it's already started. And okay, it found the binding, it's initializing, and it's starting. Okay, great. So there we go. So now what I want to do, I want to get the container ID of that one that I just launched, because we're going to actually hit it. So Docker PS. Okay, so the container ID is this. Let me get the IP address. Okay, so now I'm going to take this IP address and let's actually plug this into IE. And so this is it's 0.2.1 that I packaged before. If I refresh this, I would expect it to crash because this is the old IP address that I had running. But what I'm going to do, yeah, there it is, it crashed. So I'm going to swap in the IP address that we just launched in this new container. And again, it does its kind of first time ASP.NET startup deal. And there we go, 0.2.1 running. So this is that application running inside of a container, talking to a MySQL database. It's also running in another container. So this just kind of demonstrates how easy it is to do that. And just in case you're thinking, oh, well, that's easy because you're using ASP.NET Core. You can do this with full framework IIS apps. You just have to create an init hook that does some DSC to set up IIS, the sites, and enables that feature. I've also created containers that are running 2002 Delphi apps that use COM and COM Plus applications with Habitat. So that was interesting, but it worked. And so if you can run it with Habitat, and if it runs on top of basically Windows Server 2016, which is about as far back as you can go with a Windows container, it should be pretty easily containerizable with Habitat. So that is that's pretty much everything I have. If there's any questions, I'm happy to take those. Jeff, I don't know if you've seen anything pop up while I've been blabbing off here. Let's see, I'm going to stop sharing. Okay. Oh, if you stop sharing, you can see the chat window. That's nice. Jeff, I think you're muted. I think you were muted, but oh, is there a central server that coordinates the supervisors? So the nature of the Habitat supervisors is they're decentralized. And so the Habitat supervisors use a gossip protocol to gossip amongst themselves. So it's completely decentralized. Now, you may be wondering, well, if it's completely decentralized, I mean, how do I have some kind of a center of management? Well, one thing that we suggest, just in terms of getting everything set up, is adding into basically your bootstrapping mechanism. You know, whether or not you're using some Terraform or what have you to actually get the supervisors on the machine in the first place. But once the supervisors are on those nodes, all of the communication is gossiped among themselves, and they expose an endpoint. All the supervisors expose an endpoint, JSON endpoint, where you can get metadata about what's happening about its supervisors and all of its neighboring supervisors. One thing that we plan on doing with Habitat later is doing kind of some dashboarding to make it easier to see your fleet kind of at a distance through Habitat. But yeah, it's all decentralized. see, we are. All right, I don't see any other questions. Let's see, Jeff, are you still there? I don't.
I am.
Okay, good. I just want to make sure.
I've been monitoring the questions. We don't have any questions for you except that one from Eric Hexter.
Okay, great. I've had Zoom sessions where like this, I had like one or two happen where I get dropped off the audio, and as far as everything looks to me like everything's fine, but then I find out for like 5 minutes of my audio is just lost, and so like glad to know that didn't happen.
Yeah, it's all good.
Cool. Great.
All right. This is the opportunity for the attendees to put any questions in the Q&A window if there's any questions that we have right there. And
also, you know, be aware that if you have a question that comes up later, or maybe if you're watching this via video after the fact, definitely check out our website. On the website, we have links to our Slack channel, to our forums. So that's habitat.sh is our website. You can contact me directly via that Slack, but we have a very active general channel in that Slack community, and you should definitely get an answer to your question via one of those channels.
Awesome. Well, is there a method where attendees can get in touch with you if they do have any questions after the fact?
Well, so there's the Habitat Slack. There's also, my Twitter is mrockx, and I'm, you can ping me there, and we can take stuff offline. That's the best way to contact me directly.
Awesome. Well, thank you very much, Matt. I really appreciate the presentation and sharing Habitat with us for deploying .NET Core applications. And for all of you attendees, this recording will be up. You can share it with your colleagues on youtube.com/clearmeasure in the Microsoft DevOps user group playlist. And please join if you have not joined. If you have colleagues that have not joined the meetup group on meetup.com, join that so you'll get notifications of the next presentations as we lay them on the schedule. We have several that are just about to hit the schedule, so you don't want to miss those notifications. And thanks for dropping in for the Microsoft DevOps user group. Hope everyone has a great day.
Thank you very much, everybody.